Alright guys, today we're going to be focusing on our next topic, which is going to be on inequalities. We're still going to be doing in the algebra unit, as we're going to be continuing. So we're going to be focusing on, pen working, okay. We're going to be focusing on inequalities. And inequalities are almost like equations, but instead of using an equal sign, they use the less than sign, the greater than sign, less than or equal to sign, and then the greater than or equal to sign. Okay, so that's what the inequalities use. But solving them is the same exact way as equations. But the only rule you need to remember, this is very important. When you multiply or divide, you're going to need to flip the sign. Right? So say, for example, if I had negative 3x is less than or equal to 9, okay? If I divide both sides by negative 3, right? Then I have to flip the sign to a greater than or equal to negative 3, right? And you only need to do this when you're multiplying or dividing by a negative number, okay? So you're gonna when you're multiplying or dividing by a negative, you need to flip the sign, and I'll rewrite it more clearly. Let me clear this board here. So I'm gonna say number one rule that you need to follow always. I'm gonna say when multiplying or dividing, so for both, this rule applies to both of them. When multiplying or dividing by a negative number, you need to flip the sign. And I had shown you just an example how what I mean by that, okay? So with this rule in mind, and now that we know how to solve equations, right? And now you just need to solve it the same way you solve the equations, but also keeping this rule in mind, okay? So let's do a example, right? Let's do negative 3x plus 4 equals to, let's say, 25. Okay? So, first thing I'm gonna do is the same thing as you're solving an equation. What would I do? Well, this is an equation, right? But what if we had turned this into an inequality? So let's do, it's gonna be greater than or equal to negative 25. Okay, so what do? Well, we're just gonna try to isolate the variables. So let's do that. So subtract 4 on both the sides. Try to isolate the variable. Oops. Let me make that straighter. Okay. So then I get negative 3x. Let me do that in a different color. Negative 3x less than or equal to 21. Now, since I'm subtracting 4, it does not matter. I do not have to flip the sign. But when we're coming to this next part, what do we have to do? We're going to divide by negative 3, right? But I am dividing by a negative number, right? So what do I have to do? I have to flip the sign. So I'm dividing by negative 3 on both the sides. These two cancel out. And then, what do we get? We get x is going to be less than or equal to negative 7. Okay? Because I flipped the sign to become from a greater than or equal to a less than or equal to. Okay? So solving inequalities are that simple. They're not that hard, but there's a different way you're going to be graphing. Instead of graphing it on a coordinate plane, like you do with normal equations, or when you're solving for slope-intercept form, you're going to be graphing this on a number line. Okay? Let me actually get a straight line out. Let me get this. Okay. Then let's get out the red marker, put the arrowheads. Okay, so then I'm going to say this as, let's do -7, -6. Actually, you know what I'm going to do? I am going to say this as -9, -8, -7, -6, -5, -4, -3. Okay, so there's two things you need to know. When you are graphing that is greater than, I'm gonna make another area here. If you're graphing one that has a sign of greater than or less than, you're gonna use something called a open circle when you're graphing it. Okay, that means you're not coloring it in. You are not coloring it in. But if you have anything a greater than or equal to, or a less than or equal to, you are going to use a solid circle, meaning you're gonna color in the circle. Okay, and what I mean that is you're just gonna draw a line, right? So since this case we have a less than or equal to, we're gonna put in a solid dot, and we're gonna put it right there above -7, but we're not done yet. Since this is less than or equal to, right? We covered the equal to part. The solid dot represents that. Also, this including all of the including -7, but less than or equal to x less than or equal to -7 means all of the numbers less than or equal to -7. So what do we have to do? You're gonna just draw an arrow like that, pointing to the left, since it's less than or equal to, and all of the values that are less than or equal to -7 will satisfy this. Okay? And if it was greater than or equal to, then we'll do it towards the right. You would do it towards the right because all numbers greater than or equal to -7. Okay? So that's how you would solve a simple inequality. So there are different types of inequalities. The one that we just solved is called a simple inequality. A simple inequality. Now let's move on to the other type of inequalities, which is called a compound inequality. Okay, so let me erase this. I'm not going to clear it because I want to keep the number 1 rule up there, so we always remember that. Okay, so compound inequality would be something like this. So I'm going to give you an example, and then I'm going to walk you through on how to solve it. So for example, let's say let's do -4 is less than or equal to 2x less than let's say 6. Okay, so what you're gonna do here is your goal is also to isolate the value x here. So what I'm gonna do, I'm gonna divide by 2 on all of them. And after that, if I divide 2 on all of them, then I get -2 less than or equal to x less than 3. Now, I'm not dividing by -2, I'm dividing by 2, so I just keep the sign the same. Okay? So now I get this. And you might be thinking, well, this is going to be the final. And you might be thinking, how am I going to graph this? Well, again, let's bring out the number line. Let's bring out the number line. Put the arrowheads. Okay, so what you're gonna do is I'm gonna go like this. Let's do -3, -2, -1, 0, 1, 2, 3, 4, 5. Okay, so first I'm going to put, now if I were to write this, I'm gonna write this as 2 different inequalities. I'll write this as x is going to be greater than or equal to -2. And the reason why I flip the sign is because normally you want it written as the variable that comes first. If it's written like this, as -2 less than or equal to x, and you want to change it from x, and bringing the x into the front, then you need to flip the sign like I did here, okay? But here, I'm going to keep the sign the same here, because x is going to be less than 3. So, first, I'm going to do x is less than or equal to -2. X is less than or equal to. So that means I'm going to go there. I'm going to fill in a solid dot, and then x is less than 3. So just less than, not a solid dot. It'll just be like that. I don't want to fill it. Let me fix this a bit. Okay. So then I want to just do a normal dot. Then I'm going to connect this, because that means this equation, or this, inequality will satisfy any values between -2, including -2, and to 2, because we're not including 3, because 3 is not included on this, because it is not solid, right? So that, this will satisfy this equation, okay? But there's also, in the compound inequality, there are also two different types of inequalities. There is something called an AND inequality and an OR inequality. OR inequality would be like x less than 5 or x greater than 6, and AND will be like -2 less than or equal to x less than 3. That's an AND, the one that we just did here. An AND graph would look like something like this. Now I'm gonna go over some tips on it. So let me clear this. Okay, so let's first talk about the AND. So the AND is gonna be look something like -2 less than or equal to x less than 3. Okay, and the graph would look like this. It would have a range of values, and this range of values would be the values that satisfy this equation. Or sorry, not equation, inequality. It's really hard to saying inequality when you got used to saying equations a lot. So this will satisfy this inequality, okay? So then now let's take a look, since we got a little bit familiar with the AND, because the example that we did was an AND inequality. Let's look at an OR inequality. So an OR inequality will look like x greater than or equal to -2 and x less than 3, right? If I were to graph it, it would look like this. Like something like that, okay? Yeah. So that would be the OR inequality, right? So now I'm actually going to graph these I'm actually going to graph these, and I'm not going to, these were just examples. I'm showing you briefly on what the graphs look like. So if I were to graph this, you're basically saying that, let me write it. So -3, -2, -1, 0, 1, 2, 3. Okay? So here, basically, you're saying that x will be greater than or equal to -2. So greater than or equal to -2, and then x less than 3. So then this will be the range. That will be the range of the values, okay, that satisfy this inequality. Okay. So now, what about the OR? What about the OR inequality? So let me draw this graph here. Right, then first let's do -2, -1, 0, 1, 2, 3, 4. Okay, so now so x is greater than or equal to -2, so that means greater than or equal to, so I'm gonna draw it like that way, and then I'm gonna use a different color for the other one. X is less than 3, so just less than, not less than or equal to. So there we go, right? I graphed both of these, and this graph would satisfy this inequality as an OR inequality, and this graph would satisfy this inequality as an AND inequality, okay? So now also, they might ask you, like, what is the union or what is the intersection, as we'll be referring to the set theory. As we said, that union is going to be everything, all elements, and the intersection is going to be just the common elements, okay? So in this case, if I were to ask what is the intersection, then you would say all